If you think about modern communications, you think about Bluetooth, you think about your cell phones, you think about internet, you think about satellite. All of that is built on wireless communication. And for wireless communication, you need antennas. My name is Teanette van der Spuy, and I am a PhD here at the Antenna Group in Chalmers University of Technology. So my work is on phased arrays, and I work specifically with satellite communications. When I finished high school, I was sort of torn in two directions. It was either going to be engineering or languages. And in the end, I chose engineering, at least partially because of the flexibility and the abundance of job opportunities. But I did something I'm very passionate about. But I kind of find it poetic that I'm here working on antennas now and communication systems, because communication systems kind of feels a bit like languages once again, which kind of harks back to my other passion when I was growing up. I started here with my master's in 2020 actually, in the pandemic. So it was me and my husband, we came together here from South Africa. We were starting to look for master's theses and kinds of topics, and did a master's in the topic of phased arrays, and it sort of grew naturally from there. You know, the doors opened, and they have a bit of a saying, if you can do antennas, you will do antennas. Phased array antennas are extremely flexible. So to explain that, I'm just going to give you a short overview of how they work. So a phased array antenna, instead of having a single antenna, you will have many different antennas. So you'll have a stationary antenna, but you'll have a signal that goes in all different kinds of directions. And this is useful, for example, in cell phone base stations or just the general communications. If you want to send more of your signal in a specific direction, you have a greater demand in a specific area, you can do that with a phased array. Or in the case of my work, if you have a satellite which you need to track across the sky, and make connection, track it until it disappears over the horizon, and then very quickly make a connection with the next satellite, then these phased arrays are really what you want. The first time I walked into an antenna lab was in South Africa, and at the University of Pretoria they also have a very big compact range, and at that point it was almost sacred. You know, we had a very specific excursion that we could go to, and only this specific course would take us there, and we were all very much prepped beforehand. And of course, when you enter that, you don't necessarily know what to expect. That will always stay in my mind. Entering this lab, it was nice to see it looks familiar. It looks very much like the one we had in South Africa. This one has slightly different dimensions, it's for slightly different frequency ranges, but it still harkens back to that first time, that sacred experience. This room is kind of like a music studio, but for antennas. So if you imagine a music studio and you want to record a very specific sound, there's two very important things. Firstly, you don't want to have noise from outside. And secondly, you want the sound inside to be very pure. So you don't want, if somebody's singing, their voice to be tinny because the room is metallic or something like that. And for antennas, it's exactly the same. So we have a big metal enclosure, which is where we measure our antennas, and it kind of acts a bit like a Faraday cage, so it keeps all the noise out from the outside. We also have very specific material inside the lab, and that's to absorb any reflections. So that if you have your antenna, which you're measuring inside the lab, you get a very pure, very clear measurement characteristic from that device, just like in a music studio. I find sound is a very good analogy, because with the antenna it works with electromagnetic waves or radiation waves. But fundamentally that's not any different to sound waves, it's just the different frequencies. So as a sound travels through the air with waves, so your signal, your electromagnetic information that you're transmitting with your antenna also travels through the air. Personally, I'm very much involved with satellite communications, and we see a big boom there for many different reasons. I think there is such a huge communication network on Earth, but there are challenges with that in terms of natural disasters, in terms of war. We need different solutions. So I really think satellite communications are here to stay as well. And it's interesting because it's an old technology as well. We've had satellites for a very, very long time. But it's only recently that it's become a possibility for the average person to actually make use of satellite internet. And I hope that that technology will continue to develop, will become more affordable, and very crucially, more energy efficient. And that we see with that push that it becomes even more accessible for people to use. And I think that's a general comment as well. Even the terrestrial communication here on Earth, we see a very big problem with that. We have increased coverage, but we have a massive energy usage, which I think a lot of work is going into to solve.